If you're out there on the floor doing the daily grind, cleaning, inspection, maintenance, repairs, listen up, because this explainer is built exactly for you. Today, we're diving into a critical daily reality, the 5 essential checks you absolutely have to make before you even think about removing a machine guard. It's all about making sure you go home safe at the end of your shift.
You know, it's incredibly easy to look at a machine guard as an annoyance, right? Like it's just some piece of metal, mesh, or plastic that's constantly getting in your way when you just want to do your job. But the reality? That thing is a literal life-saving barrier. Right behind it, you've got rollers, belts, gears, crushing points, maybe some intense electrical or pneumatic energy. Pulling off that guard means you are stripping away your primary line of defense.
So, before you loosen a single bolt, we've got 5 checks to run through. Safe stop, lotto applied, authorization and communication, residual risk controlled, and finally, test before intervention.
Let's jump right into check 1, safe stop.
Okay, here is a massive myth we need to bust right out of the gate. Stopped absolutely does not always mean safe. A machine can sit there looking completely dead, totally silent, but still be incredibly dangerous. Why? Well, it might be programmed to restart automatically. Or maybe it suddenly gets a signal from a remote sensor, a PLC, or a totally different part of the line. Maybe a cycle hasn't even fully finished yet, or heavy moving parts are just taking a long time to slow down. You've always got to ask yourself, is the correct machine stopped, and has all the movement truly 100% ceased? And we really need to get this straight. An emergency stop is exactly what it sounds like. It is a panic button for a dangerous, unexpected situation. Period. It is definitely not a safe isolation method for your daily maintenance access. Relying on an e-stop to protect you while you're inside a danger zone, that is a massive, life-threatening gamble. Just don't do it.
The harsh reality on the shop floor is that just hitting the stop button is literally only the beginning. A stopped machine can still hurt you if you haven't taken the next vital step.
Which brings us to check 2, lotto applied. We see these daily shortcuts all the time, and they are so dangerous. A push button, a selector switch on a screen, or a buddy shouting, "Hey, it's off," from across the floor, those are not energy isolating devices. A real isolation point is a physical disconnect switch, a valve, a breaker, or an approved block. That's it. The rule here is absolute. No LODO, no access. Lockout physically isolates the energy. If it's not locked out, it's simply not controlled. And look, if your personal lock isn't snapped onto that isolation point, you are not protected. Your lock is the one and only thing guaranteeing your life while your hands are deep inside that machinery.
All right, moving on to check 3, authorization and communication.
Picture this super common day-in-the-life scenario. Maintenance thinks the machine is fully isolated and safe to work on. Meanwhile, production assumes the machine is just sitting there available for use. And the operator? They think this is just a quick, temporary stop to clear a jam. It's a recipe for disaster. So many tragic accidents happen simply because different teams make completely different assumptions about a machine's status. When people stop talking, someone gets hurt. That is exactly why a guard is only removed with strict authorization, control, and clear communication. Is there an actual work order? Has this task been planned out? Have the nearby workers and production operators been explicitly told what's happening? You need barricades, you need clear conversations, and total alignment to make sure nobody walks up and hits the start button while you're elbow deep in the equipment.
Next up, check 4, residual risk controlled.
For daily maintenance tasks, this right here is the silent killer. You've stopped the machine, you've locked it out, but what about the energy you can't actually see? A single trap pneumatic line can easily hold over 100 psi. That is way more than enough to trigger a blade to cycle or cause a heavy press to drop unexpectedly. You have to actively ask yourself, what can still move, fall, or release pressure? You've really got to map out and neutralize these hidden energies in real-world situations. Think about your actual daily tasks. A pneumatic cylinder? It holds trapped air, so you need to vent it. A suspended part? It's fighting gravity, so you must mechanically chock it. Even the heavy machine guard itself holds gravity. A standard industrial guard can easily weigh over 50 pounds. If you just zip those bolts off without securing it first, that entire weight is dropping straight on you. So you have to take exact physical actions on the floor to prove that machine is completely safe. You vent or drain the lines. You discharge those accumulators. You mechanically block any cylinders or moving parts. Secure the heavy covers. Give hot surfaces time to cool down, and let rotating parts completely stop turning. You've got to actively hunt down and neutralize every single hidden hazard.
And finally, check 5, test before intervention.
We often call this test before touch, or the tryout. Simply put, it's the act of verifying absolutely zero energy before you put your hands, your tools, or your body anywhere inside that danger zone. It's the ultimate moment of truth where you prove that your lockout and your venting actually did their job.
So how do you do it? Well, if the procedure allows, you actually try to start the machine from the normal controls to make sure it fails to start. You check for an absence of voltage. You physically look at the pressure gauges to ensure they read dead zero. You confirm that pneumatic cylinders just don't move. And hey, this is huge. After you test it, always return the controls to a safe off position so the machine doesn't suddenly spring to life the second power is restored.
This is basically the golden rule of maintenance. Before you touch, test. Don't trust your memory. Don't just assume a gauge is broken or that a valve held tight. Verify everything. Prove to yourself that the machine absolutely cannot move.
Now, once the job is successfully wrapped up, there's one final non-negotiable rule. The machine does not return to production without the guard installed. Period. Never leave a guard off just because you think, oh, I might need to tweak something later. The guard must be correctly reinstalled, fully secured, and checked before any operations resume.
When you put it all together, these checks build a predictable, life-saving rhythm for your day. 1. Safe stop. 2. Lotto applied. 3. Authorization handled. 4. Residual risks controlled. And 5. Test before access. 5 steps every single time.
If at any point during your shift, any single one of these checks fails, like a gauge doesn't drop to zero, a lock is missing, or honestly, if you just have a bad gut feeling, you stop. You step back, you report it, and you make the situation safe. Never, ever push through a doubt just to get a job done faster. It is never worth it.
Let's wrap up with this final thought. Next time you're standing out on the floor, wrench in hand, staring down that machine guard, if even one of these 5 checks fails, are you genuinely willing to risk your life for a shortcut? A machine guard isn't just metal or plastic. It's the barrier keeping you alive to see tomorrow. Treat it with the respect it deserves, stick to the 5 checks, and make sure you walk out of that facility the exact same way you walked in. Stay safe out there.